This is my self-study titled Using Archery as a Way to Understand My Mathematical Processing. This video is a video about my plan B, it was a paper and now I made it into a video, and I'm submitting to the Department of Curriculum Studies, College of Education at the University of Hawaii in Manoa, in partial fulfillment of the requirements for the degree of Master's in Education in Curriculum Studies. I hope you enjoy it. My name is Abraham, and first I want to start by thanking Dr. Tara O'Neill, who was my advisor for this research and who is also my STEM Square professor. I also want to thank Megan Ikemoto, which was my second reader and was one of my instructors during the first summer of my STEM Square journey. In this journey, I focus on how to apply different mathematical processing models and the content in which I experience mathematical processing, and I try to investigate the complex link between mathematics and archery. So how does the context in which I use mathematics affect how I process it? That's my research question. The context of how I process mathematics. So I want to explore the different processing models that produce anxiety with the following claim: that mathematics anxiety level depends on the processing model required to solve problems. And this is because anxiety strongly impacts my ability to process mathematics and the models I feel comfortable using. This study findings emphasizes the need for processing models for measuring the severity of math anxiety and the effect of stress in mathematical abilities. Without further ado, I'd like to give you a little bit of a background on how my story with mathematics began. When I was a child, I remember sitting in the table with my family, looking at my uncles play dominoes. And I was raised in a pretty unpredictable environment. Domino playing when I grew up was pretty competitive. And I remember my uncles and my family overall just battling and using different strategies to try to win domino matches. And as I sat there on the table, I remember looking at the tiles and looking at the little dots on the dial, on the domino tiles. And that's how I remember to interpret numbers. So in my mind, the tiles represent a numerical figure. Instead of a word or the symbol of a number, I did math, and I remember doing math by following the tiles. So I became increasingly aware of the value of those black dots as I just memorize them and remember how they were. So what was the problem? Well, the problem with mathematics actually started way back then. And here I have a picture of my family, and I want to bring them into this space because my family has played a very important role in my relationship with math. Particularly my dad. There was a moment in my life when I was a kid where my dad got into a car accident. We were at the beach and he had a little bit of too much alcoholic beverages, and he asked me to step outside of the car after we got home. And I remember my mom and my dad getting into an argument, and my mom did not want my dad to leave. Shortly after he did leave, a couple of his friends came over the house asking my mom to get in their car so that they could take her to the hospital because they had found that my dad had gotten into a car accident. And shortly after that, my dad passed. So that moment as a child really had an impact in me on how I did in school. So here on the right, I have a picture of me and my friends, and there I'm wearing a blue jacket. That's what it seems like, and I'm putting my arm over the girl that I liked at that time. But this picture of me when I was in fourth grade represents the moment when I actually had an incident in a classroom where, from what I remember, I was learning how to solve fractions, and my math teacher at that time asked me to step to the board to do some mathematical exercises, and I couldn't really figure out how to solve the answer, so I started looking over my peers' work, and she thought that I was copying. For whatever reason, I'm not sure really what happened, but she didn't have the composure or the patience to deal with me at that time. And so she made a fist, and with her knuckles, she hit me in my head in front of my class. And at that moment, I feel very, very embarrassed, particularly because all of the rest of my peers had already sitting down and I was the only one standing. And so that context of solving math in front of my peers, in front of a group of people under a time restraint, really put me in a lot of stress. And that negative emotion translated into how I developed my relationship with mathematics later on. So the problem really is, how does the context in which I use mathematics affect how I process it? The presence of math anxiety and my struggle with mathematical processing is something that I've had struggle and wrestle with for a really long time. And what I'm really trying to understand is how I process math now. I learned through this study that I show symptoms of math anxiety, and I wanted to explore the need to understand my processing so that I can address that by answering how I can overcome and what strategies can I use to overcome. So I needed to understand what is the root cause of that problem. And to do that, I dug into the literature. So I want to bring up front the literature that I researched, and I want to start with the concept of the self-study. So I found the work of Samara's, and I use her Kipling 6Ws model, which are the what, the why, the how, the when, and the who of self-study. And those W's, those questions help me to dig into myself and really get to know more about myself and my mathematical processing. And in that journey, what I learned was that I really needed a team of people to help me. So I am thankful of my mom, my auntie, my niece, my cousin, my wife, and all the people that have supported me in this journey. I'm also very thankful of my cohort. Cohort 8 has been there to support me since day one in this past year, and I've been able to get to know a lot about myself and in regards to math and in regards of just being in the place with them. The other literature that I found was Anderson, and his focus was on math anxiety and processing models was with Ludenberg. Ludenberg talked about math anxiety in the context of educational setting and encompassing the feelings in specific situations like exams and the overall learning of academic development. I found Merlot, and I did read both of his books that are focused in archery and science and the science of ballistics. But as I mentioned before, with the work of Anderson and Ludenberg, they focus a lot on the context. And for that reason, I want to highlight that in the context of school and solving problems under a time restraint, I do experience math anxiety. Under the context of taking a test like a standardized test, like the ASVAB or the Praxis, which I've taken before, I also experience math anxiety. Under the context of archery, where I don't have a time restraint unless I'm trying to shoot an animal with my arrow or something like that, I am very relaxed otherwise. So the endeavors for me to get a high ASVAB score to join the military was something that helped me to realize that mathematics was always geared towards people that could. And that's why I have a picture here of me. I'm a Army veteran. I did work as a airborne in airborne operations, and while I was doing that, I realized that mathematics is asked. Like, if you want to go into elite training, you need to perform, and you gotta have that mentality of being able to solve problems quickly. And that is exactly what D'Ambrosio in 1985 brought up in his research of an ethnomathematics. Mathematics under the context of culture and under the cultures of being available for everybody, not just for the elites. At this time, I'd like to talk to you about the methodology that I use for my research. I use quantitative methods for archery and qualitative methods for all the different reflections and data about myself that I looked at. For archery, my quantitative methods was ordered in graphs as I kept scores of where my arrows landed after I shot at targets that were at 20 yards all the way to 60 yards, and some of them at different angles. I also kept a journal where I made anecdotes of the wind and the weather and the conditions that I was shooting at. And so for archery, my qualitative analysis indicates some varying in scoring across the dates that I gathered my data, suggesting that there were some factors that affected my performance from 20 to 60 yards, and I'd like to show you that data in a little bit. Throughout my personal reflection, I also looked at the 2017 math notebook that I use for practice for the Praxis exam, and I did identify in that notebook the presence of anxiety. So again, I want to explain that in the context of school, and as I remember from looking at my work of a book that I wrote in 2020, and as in the context of taking exams under time, I do experience math anxiety under that context. But in archery or in sports overall, I don't. So my implementation of the study went in different phases. The first phase was a review of a book that I wrote in 2020 titled 1,000 Pounds of Physical Education, Winning the Gold in Life and in Your Classroom. And what I did was I reread and made a sympathize or reread the first chapter, and I looked at the challenges that I talked about in that chapter as I was going through school in the classroom, and also as I was doing standardized testing. I also wrote on that book about the work that I did for my first master's program, which was in elementary education, and how I compared the effects of high intensity interval training versus mindfulness in a second grade classroom before a math block. And that was the work that I self-published in my book. And I just kind of did a summary of that chapter and wrote about some of the reflections that I thought that were linked to math anxiety. The second phase is the data that I gathered from my praxis exam and also a test that I took online that is for math anxiety. And the third phase of my implementation of my work and my methodology, I started observing the trajectory of the landing of my arrows, and I started a kilo or a observation book where I am in that notebook. I wrote my observations of my performance in the summer when I started in the summer in 2022. So what were my findings? Well, my claim is that my mathematics anxiety level depends on the processing model required to solve the problems. And this is because anxiety strongly impacts my ability to process mathematics and the models I feel comfortable using. So for this claim, there are two parts that I like to highlight. Number one is my findings in mathematics anxiety. And number two, the models in which I feel or in the models in which I don't feel comfortable using. So focusing on the first one, in the first part of my claim, I talk about my mathematics anxiety levels depend on the processing. And what I did was I reevaluated the social and emotional events and the place where I was. And when I talk about place, I don't necessarily talk about a particular geographical location. So what I did was I took a quote from my book and I reflected on what I said. So let me read this quote to you. I have learned to accept that I miss my father, my grandparents, and those who supported me during my childhood. Even so, though sometimes as an adult I cried about my dad because I no longer have him and my grandparents around me, I remember them dearly. So as I reflect on this quote, I notice that I am accepting and understanding that I need to forgive, but forgiving and forgetting are two different things. So I am forgiving myself, forgiving my dad, but I do remember the moment that he left. And although I forgive my dad for leaving me and getting into the car accident, and that later on affected me as I was a child, I have not forgotten the bond that I had with him, and I have continued to build on that good memory. And as a result, I began to take steps towards overcoming that loss. So other than that, I also dug into the analysis of the findings of my archery, because that is a place where I don't feel anxiety. And when I am doing mathematics for archery, I feel very comfortable. And I like to explain that what I mean by doing mathematics in archery is simply putting arrows on the target. It's adding arrows to the target. Pulling the arrows from the target is simply subtracting arrows from the target. Dialing in your compound bow or your recurve bow, you do use fractions. And if you look at the literature from Merlot, he talks about Galileo, Leonardo da Vinci, Plato, and many other different scholars that did research, did math, and study the science of ballistics. And in the context of archery, there is a lot of mathematics. There is the swing, the angles, and the paradox of the arrow, and there's a lot of complex things. So again, archery or any other sport in whatsoever, but I'm focusing in archery as a context for this research, can be used to encourage children or people to learn and find how to cope with mathematics in a more comfortable way. Again, I'm using archery and I'm giving you an example of how it would be used in a simple way of like adding or taking apart using fractions, decimal points, which are used in compound settings, and also the a little bit more complex um, angles and shot placement and cut charts, and transferring those into um, where you put your arrow in the target. So I wrote a quote after my reflection of how I process mathematics through archery, and it says, I've come a long way since day one. In the early stages of my archery journey, I often experienced math anxiety that would affect my performance. I would overthink calculations, doubt my abilities, and feel a sense of panic when I faced mathematical challenges. And so I reflected and I wrote, this quote indicates that I have initial difficulties with math, leading to anxiety that impacted my archery performance. So I noticed, and I will show you that in a little bit, that there was in the beginning of my practice, of when I started gathering my data, I wasn't doing as good as I did later on. Another quote that I wrote was, over time, as I engaged in regular archery practice and confronted my mathematical concepts head on, I gradually noticed a decrease in my math anxiety. I developed a more confident mindset and better understood how math relates to my archery techniques. And as I reflect on this quote, I realized that it shows that my math anxiety began to diminish with consistent practice and comforting my math-related challenges, allowing me to focus more on improving my archery skills. Here's another quote that I wrote. Through my archery journey, I have learned that mental math is crucial in precisely hitting targets. It's no longer a source of anxiety for me, but a tool I have embraced and integrated into my training routine. Math has become a means to enhance my overall performance and achieve accuracy in archery. Again, this is a quote that I took from the journal that I kept, that I started since 2022 in the summer, when I started observing the trajectory of my arrow. And after looking at these quotes in this particular reflection, I noticed that I have evidence that I have begun to overcome anxiety, and I recognize the importance of mental math in archery and actively incorporating it into my training. So math began to be a source not of fear, but it was actually an asset as I began to think more mathematically as I practiced something that I enjoyed. So where my evidence with my qualitative data begins, it took some time for me. This honestly wasn't an easy task, but initially I saw that my points were relatively low when I started. My scores, when I started sighting in my compound bow, I did not group. That's what it's called in archery, when your arrows are grouped together. But as I continue, I started noticing an upward trend, and eventually I started to see process, and then I saw a plateau, and eventually there were fluctuations. And as what I did do during this methodology was I organized my data into charts, and I had a lot of raw data that I didn't want to bore you with, but what I did was observe throughout a period of about 3 months where my arrows were landed as I was sighting in my compound bow, and what I was doing, what mathematics I was doing to make this process more effective. So my second finding, and this is the second part of my claim that I now would like to focus on. So the second part of my claim is that anxiety significantly influences the models I feel comfortable using and how I understand mathematics. So my literature talks about the different mathematical models. And what I like to explain here is that in the literature, I found six mathematical models. And out of those six mathematical models, I showed that in the context of doing math in a classroom or for a test, I saw anxiety. And in the context of me using math for daily living things or other sports or in archery for the purpose of this study, I did not. So what I'm going to do now is I'm going to explain the six mathematical models, and then I'm going to share with you in which one of those I did have math anxiety and which ones I didn't. Processing models that affect anxiety include computational methods. And so computational methods pretty much is anything that has to do with calculations that come out of a computer or a device such as a calculator or anything electronic. And those methods sometimes for me produce anxiety if I don't know how to use certain keys under a time restraint. So I do know how to use a calculator, but on a test, when I'm given a calculator to solve a mathematical problem and I only have 1 minute to solve that problem, if I don't know how to use a calculator, I see signs of anxiety. And depending on the problem I was solving, I noticed how I struggled using different computational tools. The next model I want to talk about is symbolic manipulation. Symbolic manipulation involves working with mathematical symbols and equations and formula to solve the problems. Now, I did understand the formulas, and it took a while for me to find the gap of where I was going to use different parts of the formula, like fractions in algebra and solving algebraic equations and that sort of thing. When I feel anxiety was when I was doing symbolic manipulation under a time restraint for a test. Also, if I had teachers who portray math as hard and as complicated with those symbols, and they had an impression that I was doing bad at it, that teacher might have had still in me some type of worry or fear that made me feel anxious. The next model I want to talk about is called visual representation. And this approach uses visual aids like diagrams, graphs, and geometric shapes so that we can understand mathematical problems. It is often used when you're representing data or graphic functions. And in me, it triggered anxiety if I was in front of a class and I was making mistakes in front of my peers, and I felt, like I needed to perform a little bit faster or explain the data a little bit better. And if I didn't know how the graph was looking or what it were the variables that I was trying to represent, I felt a little bit anxious there too. Now, I'd like to talk about the models that I found in the literature that after incorporating them into my archery practice, I realized I did not experience anxiety. Logical reasoning is one of them. And this approach focuses on logical thinking and deducting problems in a mathematical way. It focuses on identifying patterns and making logical connections. So I think that for me, that was a model that it didn't really trigger a lot of anxiety in me. I think that it was easy for me to read the problems and find the logic on the problems when I was under a time constraint. The next model is real-world application, and this approach involves applying mathematical concepts and principles to real-world situations, and it really just could be used in finance. Like when I talk about real-world situations, that will include doing taxes and real-world applications where you have to pay bills and that sort of thing. And the space where I felt that there was a real world application, was archery for me, and I didn't feel any anxiety at all when I had to pay my bills or use math for simple arithmetics that I needed to do, or that I was doing during the time that I was practicing archery outside, and particularly because I wasn't being timed. And then the last one is problem solving strategies. And an example of problem solving strategy will be like finding an answer by trial and error, and breaking down a complex problem into smaller steps, because problem solving strategies involve a systematic approach to tackle those concepts, those mathematical problems. And for me, the strategies, if I use them in things like cooking or woodworking, or being able to make a decision in that where I needed to solve a problem, I needed to make a decision, most often I didn't feel stressed about that, and it was easy for me to just use different strategies to make choices. And I think this is important, because that is precisely what mathematics ends up being practical in. Quite often when we're going through school, we don't really understand how we're going to use this when we in the real world. And what math does is that when we are in the real world, we have that aha moment where we say, wow, I am making decisions that are really hard, and I don't, I realize that it's because I persisted so much in doing other types of problems, which were the types of problems that I had to do in the classroom, and the types of problems that I had to solve under the test, and the types of problems that I had to solve under time restraint. So that stress actually helped me to build a resiliency in moments where I didn't have a time restraint or I didn't have stress. So in conclusion, throughout my study, it's been very clear that my childhood experiences have significantly influenced and created gaps in the way that I process math and the way that I feel comfortable using math. And I've highlighted the importance of processing models in mathematics. And I think that in the context of those models will have different contexts within themselves, where people may or may not feel anxious. So understanding this element is essential for teachers and for students to create techniques so that the anxiety level of solving math problems is reduced. And for that reason, I have several recommendations. My first recommendation is I really recommend looking into the potential advantages of incorporating extracurricular activities like archery in this case, but it could be anything else. Hey, I have a friend that likes to play hockey and rugby, and she applied chemistry and physics into how she learned how to apply it to how she could become a better hockey and rugby player by applying physics into her techniques. So she increased her relationship with her mathematics professor because she was able to put that together. So the untapped potential for such activities is highlighted by archery in this research, but unexpectedly is good. It's a great effect for any participant that have that perspective of applying mathematics. My second recommendation is that my thesis made a surprisingly yet important finding, and I highly advocate for more research into using extracurricular sports, particularly archery, but it could be any sports, to reduce math anxiety and better understand problem-solving abilities. So, in other words, if we want children to enhance their cognitive skills, it's important for us to reach them quite often outside the classroom. And with that, I would like to leave you and thank you for your time and your attention.